Good day to all. Hope everyone's doing well. Today we're going to go over the quality of service. So take a look at your topology real quick. 2 routers, layer 3 switch, end devices, serial, this cloud, which is interesting. It's an actual device. So kind of neat. And then these servers over here. So everything's empty. Let's take a look at our basic configs. So first thing we notice is we're using IP, NAT, and PAT. So there's your inside NAT. Your serial's got bandwidth, so we should assume that the serial on the other end has bandwidth that's the same. If you check the IPs, 10.1.1.1, 10.1.1.2, there's your inside NAT. Looks like we're using ospf, passive interface with the gigabit, and the zero network, which means any address. So it's a default route. And then there's your PAT overload and your access list for the NAT and PAT. So it's going to use the serial IP as the public. So whatever this IP is right here is NAT and PAT will use. And on router 1, we see pretty much the same thing, but the only thing different would be dhcp. And then down here, what we're going to do is, remember we're trying to do quality of service, and we're going to make a class map, match all, voice. And here's your protocol, RTP. So next class is going to be HTTP match all. HTTP is a protocol, ICMP, and ICMP. So there's your classes, and here's your policy map. And remember that should show up somewhere else, the name mark. So class voice, priority 100. And then if you remember, the DSCP is the congestion on the WAN. So it's the expedient forwarding. And I'm not going to get into the real. They basically look at the first 3 bits to determine things. And so there's class voice. Now we have class HTTP. There's your bandwidth restriction. And then we're going to do AF31, which is the assured forwarding. And then it's 31. If you go back to the PowerPoint, you can see what this AF31 does. And then the third class we define is ICMP, your bandwidth 25. And then we're setting to a different AF, assured forwarding 11. And then, like many of our concepts, we have to apply it to the interface. So let's get our routers up and running, get the routing protocols converged, see if the IPs work, test. So make sure you go to router 2. Quick scan, looks like everything went in. Notice we have some green lights, some amber lights. The WAN link won't come up until this serial on router 1 has been configured with no shutdown. All right, so if we want to fast forward time, you can. So I will. And we should see our ospf loading. So we'll do a do show IP routes. And you see the ospf is picking up that 8 network on the other side. So first thing we're going to do is show policy map. Shows nothing. And if we do ints0/1/0, you'll get nothing. So once again, we go down to the config. So let's go ahead and do we'll ping real quick. 8.8.8.8. We should get a few timeouts because it's going across a WAN link, and it's going to ARP. There it works. And so if you go into the, keep this right here, if you go into the router and we do the same command, obviously nothing there. So let's go ahead and pop the config in. So from here up, oh, I can't copy all that. All right, let's do it a little at a time. Let's recopy from here down. So that works. Let's do this. Better put that right here. Okay, so once again, I'm just going to copy the policy mark because I kind of, the copy and paste isn't smooth with that little explanation in the middle there. So when you get it, it should be fixed. Okay. And then let's apply it to the interface. Okay, now I'm going to get out of config and let's go ahead and show your map. So let's take a look. Here's your policy map mark, voice, and it looks like HTTP and ICMP. So now when we ping, we're going to do 100 pings. So we should now ints 0/1/0. So we're not using any HTTP or voice. So here's your voice, RTP, 0 packets. Here's your HTTP, 0 packets. And then down here at ICMP, we see 10 packets. So if we show again, we should see more packets, 33 packets. Okay, so we'll go ahead and stop that. So let's go ahead now and try to use HTTP. So let's go ahead and go to the web browser. Eight dot eight dot eight dot eight. Click a few links. Now, if we're looking for HTTP, if we look up at the last show, HTTP right here. So 0 packets, 0 bytes. So if we show again, we go up to HTTP, we have 28 packets. So remember, this is prioritizing traffic. We don't have any voice, which kind of makes me want to do voice now. That's a little bit more than I want to tackle today. And then to finish out, let's go ahead and add the FTP. So remember, you got to create your class map first. Then you match the protocol. In this case, the name and the protocol are the same. And then you create your policy map. And I'm doing bandwidth 15. Go ahead and copy this. Let's go to router 1. Don't forget config T. So it gave us a little something on serial FTP requested bandwidth 15 kbs. Well, that's positive. Now, how do we test it? So let's go to command prompt. Do FTP 8.8.8.8. Cisco is the username and Cisco is the password. So if we look now at the policy map, we should see FTP is in the class and we have 7 packets. So that is how you set up quality of service on the router. Have a good day.